Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's dive into today's daily challenge on Leetcode, where I will show you two methods of how your thinking process should evolve from O of n square to O of n in detail with explanation. So stay till the end of the video, and if you like, then please hit the like button and also subscribe to my channels because it gives me motivation to put more effort in making such videos. So let's just start. We are asked to find the lexicographically largest string from box 1. You are given the string word and an integer num friends. Alice is organizing a game for her num friends. There are multiple rounds in the game, wherein each round the word is split into num friends non-empty strings such that no previous round has the exact same split. Okay, and all split words are put in a box. Find the lexicographically largest string from box after all rounds are finished. So let's try to understand with this example first. If you are given the string DBCA, you just find all possible splits of type, right? So type means number of splits should be 2. So you can split D and the other other string will be BCA. You can split DB, then it will be CA, and similarly. So if it is 4 or if it is 3, if it is some other number, you need to adjust that accordingly. Okay. So this word, let's say it's divided into 4. So it has only one possible choices of getting divided into 4 strings. Okay. So if you can see, the constraints are like 5 into 10 to the 3. So you can solve it in O(n) square. But this is also solvable in O(n) time. We will also discuss that. So yeah, let's just start with the approach. O(n) square solution, I will say you should definitely try it on your own. It should definitely click you, and then continue watching the video. Okay. So let's just start. Okay, so what exactly are we told to find? Let's try to understand that first. You need to divide the string. If you have a string str, you have some string, let's say E, B, F, C, G, H, K, some string you are having. Okay, and you need to find the lexicographically largest substring such that it is also dividable into the other into total num friends. So let's call num friends as num initially, right? So you should also be able to divide this into num. So if you see the lexicographically largest, you should always make it start with the largest character. Okay, that definitely makes sense. So you first of all, while looking at the problem, it should click you that I will first iterate through the string and find the largest. Find the largest character, okay, which is present in the string. It should definitely start with that. Okay, so now what is the maximum length to which it can go? So of all the strings which start with the same largest character, let's say I have the largest character here, K. Let's say there are other Ks also. Out of all the substrings which start with K, and let's say it has some common prefix also, let's say K, G, some common prefix also. Out of all those, the one which is the largest length is the largest, right? That is true. So what you can do is that you know that definitely my target string will start with the largest character. You first find the largest character and keep a track that if then while traversing through the string again, if you keep a track that if my current character is equal to the largest character, then iterate through the string to the maximum possible value. So what is the maximum possible value? If you try to think, let's say you have E, B, F, C, D. So what is the largest length? Let's say you have K equals to 2. What is the largest length you can obtain? You can divide it into, let's say, length 1. This is total length is 5, right? So one of the if you need to divide it into 2, so you can divide it in this manner. Okay, but this is like 1 plus 4. Okay, so this is if K is 2, you have divided it into maximum possible value is 4, because that is the maximum length which you can obtain. If K is let's say 3, what you can do now? what is the largest possible substring that you can obtain, length of the largest possible substring. So that will be EBFCD, right? So that will be 1 plus 1 plus 3. So 3 will be the largest. So you can understand that whatever k value will be there, what I will do for what this is k, this k is nothing but num, okay? This k is nothing but num, okay? So don't confuse, this is num only. This is num friends only. Now, okay, so now you see this is 2, this is 1. So for num friends minus 1, for num minus 1 number of times, I can write num as num minus 1 plus 1. So this number of times I will choose a string of length 1, and this number of times I will choose the remaining part of the string. Okay, so what will be the remaining part? What will be the length of this string? So that will be the length will be, this is of each of length 1. Okay, so the remaining length, what will be the remaining length, will be nothing but n minus of num minus 1, which is nothing but n minus num plus 1. So this is the largest obtainable string which you can get. This is the largest obtainable string which you can get. Now, if this largest obtainable string starts with the largest suffix, starts with the largest character, okay, then you can tell that that is my candidate string, if that is at all lexicographically largest. Okay, that's not compulsory lexicographically largest, but we can try to find that in this manner. So how it will be O(n) square, I will also explain in detail while I code. So let's try to see the solution once. The n is definitely the word dot size. The length, the maximum length which I can iterate, I'm keeping n, as I told you. Maximum obtainable length is nothing but n minus num friends plus 1. Okay, I hope you understood this. Now, what I told you, that you need to find the lexicographically largest. So what you will do is that you will find the largest character which occurs. Okay, you will find the largest character which occurs. So what you can do here is that you can start with A, right? A is definitely the smallest. So you can go to all the values in the word. So you can just do auto A. You are going through all the characters in the word and just doing if x is greater than c, let's say, then c equal to x, right? Or you can do the max thing also. So now you find which is my largest character. Which is my largest character? You needed to find. So you just found out. Okay. Now what I do? Let's say this is my maximum value. Let's say this is my maximum string. Okay. So now what I can do? I can iterate through the length of the string. If I see anywhere that word of I is equal to C, this is the maximum character. So if this is equal now, what I can do, I can iterate, right? I can iterate and store my candidate string. I can iterate and store the value in my candidate string. So how I will iterate? I will iterate from a value j, which will start with I, and this j will go till I plus k, and you should also take care that j should not exceed n, right? This j value, it should have a length k, okay? But if you are, let's say, starting from second last index value or the third last index value, and the k is, let's say, 4 or 5, then definitely you cannot obtain. So you need to have this check also, and j plus plus. What you will do is that you can easily do s plus equal to word of j. Okay, you get a string s. Now you check. Now if you don't know, in C++, we can compare two string. If I mean, if s is greater than max, this means that if x is lexicographically greater than max, then put max in x. Yes, okay. This is doable in C++. You can just do a max function also, no problem with that. If you return max, okay. So does this work? Okay, so this is a character, so it should be within a single quote. Okay, so we get a wrong answer in GH. The case is like num friends equals to 1. Okay, so if num friends is 1, you can easily say that all of this greediness doesn't make any sense, because I am doing that whichever is the largest character, go and find that and do stuffs like that. But if num friends is 1, you have only one length string. You have to return the whole string, right? So if num friends equal to 1, what you can do, you just return word, because it doesn't make any sense. So we do have the accepted string. Let's try to submit it. Okay, so you see we do not have that much good runtime complexity, but it is O of n square and it works. So let's try to solve in O of n using a two-pointer method. How we will solve that, how we will do things. Let's try to check it quickly. Okay, so you see, what did we do here? What did we exactly do here is that I found the largest string. I found the largest character at first, okay, and then said that all those strings which starts with the largest character is my candidate string, and I went on comparing each one of them. Okay, I basically did this. Nothing much. Now you see, one thing is that can you somehow find an index I? Can you somehow find the index I, and you will say that that index I is the best index. What does best index means? It means that if we start taking my string from that index, then definitely we will get the lexicographically largest string. How can you say this? Now you will say that how we will suddenly get a string which will be lexicographically largest, that too in very short time. How can you do that? So what you can do, you can take two pointers here. You can take two pointers here. One pointer, one pointer will be best pointer. We will call it best pointer, and another pointer we will be rival pointer. This pointer has the capability of overcoming the best. So what does it mean? So initially we will say that best is 0, rival is 1. So we will start, the best will be here. Rival means right pointer also, you just remember it that way. It will be always in the right. So the best is here and the rival is here. We'll start it like this. We will assume that my current starting value is always lexicographically largest. Okay, and if I get another index which is lexicographically largest, giving me the lexicographically largest string starting from that index, then I will update my best pointer. My best pointer will now become rival, and I will update rival because I will just update it using some criteria. Okay, so in this way, at the end, we will obtain a value. We will obtain just the base pointer, right? And once we have got the base pointer, we can just iterate in a similar manner. Like we can do like j equal to I, as I showed you, j less than I plus k, or and j less than n. You can do this starting with I, okay, and j plus plus, and we will store answer plus equals to best. Uh, Answer plus equal, not best, answer plus equals to this word of I, and return answer. Okay, so how exactly we will do that, we will see while coding that. Okay, so let's try to see the approach. I will return to the whiteboard again for explaining. So yeah, we have this. k will be important and these subs will be also be important. So as I told you, I will keep 2 pointer, which is best. I will initialize it with 0. I'll keep the rival, which is 1. Okay. I will say best is the one index starting with which gives me lexicographically largest value. Okay, you got this. Now what I do, while rival is the rightmost pointer, right? So it should not exceed n. As we are doing a simple rival, it should not exceed n. Now one thing we need to take care of currently is that as I am iterating in my while loop, I have my best pointer here, I have my rival pointer here. Okay. So in the case where the both are having the same lexicographical order, it means that let's say both are having some character, let's say M. Okay, both are having the character M. Now we need to check that how many characters after this they both have the same value, right? If let's say M, K, P, T, similarly M, K, P, T. So these they do not make sense because they are still equal. So we will keep iterating unless they are equal. So we will see what is the value of length to maximum which it can go while not violating their order, right? So what I will do, I will place an integer len equals to 0. So what I will do now is this rival plus n, first of all, this rival plus len, we must not exceed the uh, rightmost, the what is called the n value. And what I told you, word of uh, best plus len equals to word of rival plus len. Okay. While this is true, I will do just len plus plus. Did you understand, guys? Did you understand this part? I did nothing. I have the best pointer, rival pointer with me. I have kept len equals to 0 at first. Len equals to 0. As I get, I just keep updating len value. As I see that this let's say best pointer and rival pointer. This best plus len value, len goes from 1. They are the comparison of these two corresponding things, right? I am just comparing these two things. Word plus len and base plus len, they should be equal. While they are equal, I just iterating n and I'm seeing that till what length they are equal. Okay, till what length they are equal. Now after now currently, if it has breaken out from the loop, it means that it has found some index which are not equal. Some index is already found in which after which going they are not equal. Now we need to check that which, if they are not equal, it definitely means that some index, some character between those two index is greater. So which one is greater, I definitely need to check. First of all, I will check that so this can also happen, right? This can also happen and break it out. So I will just check that this has not happened if this is still less than n, and I will now check which one is greater. Is my best has been overtaken? Is my best has already been overtaken? I will just check this. Is this value word of rival plus len? Okay. If this means that this is lexicographically now the largest because all the characters before it were same and now this is the greater one. Rival is now dominating. I can say that rival is now better. Rival is better now. Okay. So what I will do, I will just update the best value. I will just update best equals to rival. Okay. Now I should not lose the value of best. I will just storing it some in best something. I'm just storing that. And what I need to do, I also need to update the value of rival, right? Now, what will be the value of rival? It should be the rightmost portion. Can I always say that rival equal to rival plus 1? we have, you see what we have iterated so far. We have iterated uh, this value of t also, right? So we have two choices, t plus len plus 1 also, and rival plus 1 also, whichever is having the rightmost value. See, I have iterated len times t also. T means the best one. I have iterated the best one also len times, and also I want to go to the rival next pointer. So whichever will give me the rightmost value, I will just take that. Okay. Else, was this if about? If you remember, rival is better now. If rival is not better, what to do? You will just update the if you will just update the rival further, because my best is still best. Okay, my best pointer is still the best one. So I will just update the rival according to this len plus 1. Why len plus 1? Because I have iterated the value of len. I have checked that for the length number of values, they are equal. Rival and best are equal, and definitely I need to iterate it by len. Okay. So after doing all this, we have my base pointer now with you. Now it becomes really simple to understand, right? We can just store a string answer in this manner. And what I will do, I will start my iteration with the best, because starting with this will definitely give me the best value. Okay. Now I must also know that at max I can go till k. At max I can go till k, and also I should not exceed the n. Okay, I plus plus. What I will do, answer plus equal to word of I, return answer. That is all we need to do. That is all we need to do. If you did not understand this portion, comment me in the timestamp which portion you did not understand. See the video again. Don't lose hope, because this is a very good two-pointer question which you need to understand, and you need to get it to be good at it, right? You need to get it. You just cannot just skip it. So yeah, we have it. Let's try to submit it and check if we have done any mistake or not. So yeah, you see, this is O of n runtime complexity is giving you 100% bits. That was all. That was all for this problem. If you do not understand any portion in the first approach or the second approach, do comment the timestamp. And yeah, that's all. That's all for this video. Uh, Hope you liked it. And this was a medium kind of problem. Definitely, this two-pointer approach might be a little difficult to sing, but you know that O n square also work here. So definitely, this is a medium kind of problem. But I hope your day is going to be really easy. Thank you so much.